In ICP5, we are focused to show our learning, show the knowledge that we have learned on TensorFlow and Keras, the deep learning neural network using the Python coding language. And we are going to use CIFAR 10 dataset that we have shown during the ICP4, and we are using the code sample that we worked at the class for the ICP5. So first section shows the libraries, the modules we need for this. Then we loaded the data and we printed the data to make sure whatever we uh, uploaded that makes sense. And finally we actually visualized the data and added each levels to each figure, so that we know that whatever we have extracted as the data, that is a good quality data, meaning exactly whatever is stored in CIFAR 10, we downloaded those within our module. So then we go to some modeling. So there are 10 classes in CIFAR 10. A detailed description of the CIFAR 10, I have written that in the PDF file, so please consult that. And then in the model, we have used the one we have that we learned in the classroom. I didn't make any change here. So I compiled within the Adam optimizer, and then accuracy matrix is focused, of course. The model summary is shown below. Total parameters 156,074. Trainable parameters, everything is trainable. And then I chose 10 epochs, and then I started fitting with a batch size of 32. So let's see what happens. I have plotted the accuracy matrix. uh, Basically the plots are like this. You can see the training accuracy increases gradually. uh, the validation accuracy, however, increases first up to 2, epoch 2, and then it kind of saturates or slightly increasing function, but it's less than 70%. The loss is diminishing with increasing epoch, but then it's kind of saturates around 0.7. Let's see if we can improve the model. Um, so let's try a different hyperparameter, I mean different set of hyperparameters. So let's first do some dropouts. Point with a factor of 0.2. Let's do some dropouts that will eliminate the data. This will eliminate the data randomly so that we can avoid the overfitting. So that's why we are using the dropout. Then of course we compile the model. This is the model summary, and this is the fitting of the model for with epoch 10 epochs. The result shows a slight improvement, about 70% validation accuracy, and slightly better validation loss. It's diminished to 0.7 at epoch more than 6. Then but it's not dramatic. Improvement is not dramatic. So let's go to another fine tuning, I mean another hyperparameter tuning. And at this time we are increasing the batch size to 64. This is another hyperparameter. By increasing the batch size, we are accommodating more data to train and test, of course. So then when we do the fitting, these are the results. We can see that the result did improve a little bit after epoch 6. It's becoming 72%, but then I'm not sure, it's maybe due to some overfitting as well. Again, the validation loss is diminishing to zero point 0.8, but then again it increases, again it diminishes, so kind of fluctuating. Not a dramatic improvement, but we do see some changes. That is the most important for our learning. Then as the next step, I changed the I changed the number of epochs. So number of steps of learning, I changed that. So in that case, if we change the number of uh, steps, then each step it should do some more fitting. It should smoothen the fitting. Let's see if that really happens. So we are fitting the data, and here comes the model. Here comes the result. We can see that this is saturating beyond epoch uh, number of epoch 5 to 72%, and then the validation loss is becoming worse. So it's clearly showing overfitting. So increase of epoch, we are just overfitting the data. So as a next step, as a next hyperparameter tuning, I changed the learning rate to 0.001 instead of the default learning rate, which is 0.01. That actually that does not change much, but little bit of improvement in the validation loss compared to the previous one, but the accuracy is again about 72%. I've done another thing, that is the leaky ReLU activation with alpha is equal to zero point 0.1. It's a better performing, the literature says that it performs better than ReLU activation function. So that's why I'm using this. So it's better and it's faster as well. So with the same learning rate, with a batch size of 32, the result shows that it's getting better kind of. It touches validation loss less than 80% at some point, and also the module validation accuracy reaches to about 75%. It's little better. And I've added some padding as well. uh, we see that with addition of padding, um, our validation loss is not improving, it's worsening, and the validation accuracy is about the same, about 75%. So now let's see if our model can predict accurately random pictures from internet. So this is a picture from cat, downloaded from a random website. This is the one, and we can see that with 99% confidence our model predicted it to be a cat. Then a dog, uh, with 95% accuracy our model says this is a dog. An airplane, the next one, with 100% accuracy it says it's a airplane. That's a good one. An automobile is the next, with 99%, about 100% accuracy it's an automobile. The horse, with 100% accuracy is a horse. Then comes a truck, and our model says with 100% accuracy that this is a truck. So that concludes our presentation. So I have learned how to use Keras, how to use TensorFlow, how to analyze the images using these tools, and how to train my model, how to play with the parameters. In my exercise, I could not improve the validation loss or accuracy, but the main message here is, by tuning the parameter, I learned a lot about those hyperparameters, and I have seen that if I change the hyperparameters, the final fitting results do changes. So as a next step, I may be playing more with the hyperparameters, increasing the epochs more, reducing the batch size more, or I mean those type of things I should continue doing to improve my results. So that's what all I had for ICP 5. Thank you for listening. Bye.